Hello friends, I welcome you all to Only Code. I'm your host and host Rahul. Let's get started. Today we'll be learning about ArrayList in Java and its core features. We will start by an introduction to ArrayList. Then we'll explore how ArrayList operates internally, including how it handles resizing as elements are added. Next, we'll go over how to initialize an array list using different constructors. After that, we will review the main methods available for working with ArrayList, such as adding, removing, and accessing elements. We will also look at the key advantages and disadvantages of using ArrayList. Following that, we will discuss best practices for using ArrayList and examine some common real-world use cases. Let's get started. Let's understand the place of ArrayList in collection hierarchy. ArrayList is one of the implementations of the list interface, which in turn extends from the collection interface in Java. To better understand its position, let's take a look at the diagram showing the Java collections hierarchy. As we can see, ArrayList is part of the list category, which is a more specialized form of collection designed to store ordered elements with efficient access. This hierarchy structure helps us understand how ArrayList fits into the broader Java collections framework. Starting with Introduction to ArrayList. An ArrayList is a concrete implementation of the list interface in Java's collections framework. As the name suggests, the underlying data structure used to implement an array list is an array. Let's go over some key properties of the array list. Resizable. One of the most important features of an array list is that it can automatically grow and shrink in size. So, as you add more elements, the array resizes itself to accommodate them, and it also shrinks when elements are removed. Ordered. The array list stores elements in the order in which they were inserted. This means if you add elements sequentially, they will be retrieved in the same sequence. Indexed access. Just like arrays, ArrayList allows fast and efficient access to elements via indices. This means you can directly access element in constant time using its index. Allows duplicates and null values. An array list can store duplicate elements, meaning the same element can appear multiple times. It also allows null values to be inserted into the list, which adds flexibility when dealing with different types of data. Now that we have looked at what an array list is and how it fits into the Java collections hierarchy, let's take a closer look at how it works under the hood, specifically when it comes to capacity and size. These two terms are often confused, but they play a key role in how array lists manage memory and performance. Capacity refers to the total number of elements that the array list can hold before needing to resize. It's the length of the internal array that backs the array list. By default, when you create an array list without specifying a capacity, it starts with a capacity of 10. As you add elements and go beyond this initial capacity, the internal array is resized automatically. Now, on the other hand, size simply refers to the number of elements currently stored in the array list. If you have added 5 elements to your list, the size is 5, regardless of how much memory was allocated behind the scenes. Consider the array list shown below. As with all the lists in Java, the indexing starts from 0. This particular list has a capacity of 5, indicating it can hold up to 5 elements before resizing is required. Size of this list is 3, meaning it currently contains 3 elements. We will walk through the logic of how an element is added to the end of an array list in Java. The first step is to check if there is space available in the internal array. This is done by comparing the current size of the array list with its capacity. If the size is smaller than the capacity, then there is space left in the array, and the element can simply be added to the end. If there is no space left in the internal array, the array list will resize the array to accommodate the new element. The array is typically resized by doubling its capacity. This ensures that the array list can handle future elements without resizing too often. This resizing involves creating a new, larger array and copying all the elements from the old array to the new one. After that, the element is added to the new array. Finally, whether the array is resized or not, the size is incremented. This means the number of elements in the list is updated to reflect the addition of the new element. Consider an array with 3 elements 8, 12, and 26. When we attempt to insert the element 9 at the end, since the capacity is greater than the current size, no resizing is needed. The element 9 is simply added to the end of the list. The time complexity for this operation is big O of 1, meaning it takes constant time to add the element to the end of array list when there is enough capacity. Let's understand the logic of insertion at the end of array list with an example. Consider an array list with 4 elements 8, 12, 26 and 3, where the current capacity is also 4. When we attempt to insert 9 at the end, since the size is equal to the capacity, the array list will resize the internal array by doubling its capacity. It will then copy all the existing elements to the new array and finally insert 9 at the end of the list. The time complexity for this operation is big O of n, where n is the number of elements in the array list. This is because resizing the array requires copying all the existing elements to the new array before inserting the new element. Let's explore how insertion at a given index works in an array list. The first thing ArrayList does when you try to insert an element at a specific index is to check if that index is valid. The index must be within the range of 0 to the current size of the array list. If the index is out of range, the operation will throw an index out of bounds exception. If the index is valid and it's not at the end of the list, the array list needs to make room for the new element. To do this, it shifts the elements starting from the last elements towards the right by one position. The shifting happens to make space for the element you are inserting. After shifting the elements, the new element is inserted at the given index, and the list now has the new element at that position. Finally, the size of the array list is incremented by 1 to reflect the addition of the new element. Consider an array list with the elements 8, 12, 26 and 9. When we insert the element 7 at index 2, the current element at index 2, which is 26, and all the subsequent elements will be shifted one position to the right. This results in the updated array list 8, 12, 7, 26 and 9. Let's see this step by step. Consider an array list with 4 elements 8, 12, 26 and 9. We are attempting to add the element 7 at index 2. Since the capacity 5 is greater than the size 4, no resizing is required. The index 2 is valid, so the elements starting from index 3, that is size minus 1, are shifted one position to the right. This is done to create the space for the new element. Finally, the element 7 is inserted at index 2 and the size of ArrayList is incremented by 1. Time complexity for this operation is big O of n, where n is the number of elements being shifted to accommodate the new element. Let's discuss how deletion from a given index works in an array list. When you try to remove an element from a specified index, the array list checks if the index is valid. It must be within the range of 0 to size minus 1. If the index is out of bounds, Java will throw an index out of bounds exception. Once the index is verified, Java removes the element from that index. Behind the scenes, ArrayList stores elements in an array, so it cannot directly remove an item and leave a gap. Instead, it shifts all elements after the removed element one position to the left to fill the empty space. If we are removing the last element, shifting is not required. Finally, the size of the array list is decreased by 1 to reflect the removal. For example, consider an array list with 4 elements 8, 12, 26 and 9. Removing the element at index 1, that is 12, shifts the remaining elements left. 26 moves to index 1 and 9 moves to index 2, ensuring continuous storage. The updated array list becomes 8, 26 and 9. Breaking this down step by step. We have an array list with 4 elements 8, 12, 26 and 9. Our goal is to remove the element at index 1, which is 12. Index 1 is within the valid range. The removal process begins. Conceptually, we say that the element is removed, but in reality, it still exists until the shifting occurs. Next, all the elements from index 2 onwards are shifted one position to the left to fill the gap. Finally, the size of the list is reduced by 1. Time complexity of this operation is big O of n, where n is the number of elements that need to be shifted. Now, moving on to how searching works in ArrayList. ArrayList uses a method called sequential search to find an element, which means it starts searching from the first element and checks each element one by one until it finds the target or reaches the end. At each step, ArrayList compares the element at the current index with the target element. If they match, the search is complete and index of the element is returned. If the target element is not found and the search reaches the end of the array list, it will return -1, indicating the element was not found. Consider an array list with the elements 8, 12, 26, 7 and 9, and we are searching for the element 7. The search begins at the first element 8, which is not equals to 7. So it moves to the next element 12, which is also not a match. The search continues to 26, but it still does not match 7. So it moves to the next element 7. Here the search finds a match as 7 is at index 3. The search operation thus returns 3, the index of the target element. Time complexity of this search operation in the worst case is big O of n, where n is the size of the array list. This is because in the worst case the search may need to check each element one by one until it either finds the target element or reaches the end of the list. There are a few ways to create an array list. based on your needs. Let's take a look. First, we have the default constructor. When we create an array list using the default constructor, it creates an empty array list with a default initial capacity of 10. Next, we have the constructor with initial capacity. This allows you to specify the initial capacity of the array list when you create it. In this case, the array list is created with an initial capacity of 100. It can hold up to 100 elements without resizing, but it will still grow if more elements are added. Finally, we have the constructor from another collection. This allows you to initialize a new array list using the elements from an existing collection. As an example, this constructor creates an array list from a set, copying all the elements from the set into the new array list. So, whether you are starting with an empty list, specifying an initial size, or copying from another collection, these constructors give you flexibility in how you initialize your array list. Let's take a look at some of the most commonly used methods provided by the ArrayList class in Java. Add. This method is used to add a new element to the end of the array list. If there is enough capacity, the element is simply added at the next available position. If not, the array list resizes internally before inserting the new element. Get. This method retrieves the element at the specified index. Since ArrayList supports indexed access, this operation is very efficient and works in constant time. Remove. This method removes the element at the specified index. After removal, all the subsequent elements are shifted one position to the left to maintain the order and fill the gap. Size. This returns the number of elements currently stored in the array list. It's useful for knowing how many items are in your list at any given time. Capacity. While there is no direct method like capacity in the ArrayList class, capacity can be inferred through the internal working or by using ensure capacity to make sure the internal array has enough space. Contains. This method checks whether a specified element exists in the array list. It performs a linear search and returns true if the element is found or false otherwise. Clear. This method removes all the elements from the array list. After calling this, the size becomes 0, but the internal capacity remains unchanged. Iterator. This method returns an iterator to traverse the elements of the array list one by one. Iterators are useful when you want to loop through the list using enhanced for loops or manually control iteration. Let's see all of these ArrayList methods one by one using code. We'll create an ArrayList of type integer named AL as new ArrayList. The first method we'll be seeing is add. Add is used to add a new element to the list. Let's add few elements to this ArrayList AL. Printing the list. We can see that the ArrayList AL contains 4 elements 15, 3, 81 and 4, maintaining the order in which they were added. Next method we are going to see is the get method. Get method retrieves an element from the specified index. So we'll try to retrieve the element at index 1, which is 3. We can see that it has pulled the value of the element at index 1, which is 3. Let's try to get an element from an index which does not exist. al.get 7. In such a case, we'll get an exception, index out of bounds exception. So we'll have to comment it out. Next method we are going to see is the remove method. It removes the element at the specified index. So we'll be removing the element at index 2 and we'll print the list after that. We can see that the element at index 2, 81, is now deleted from the list. Next method we are going to see is the size method. It returns the size of the array list at a given point. Currently the size of array list is 3. So al.size returned 3. Next method we are going to discuss is contains. Contains returns true if the element is present in the array list, otherwise it returns false. So let's try to check if the array list contains 81. And also let's try to check if the array list contains 15. In the first case we got an output as false because 81 is not present in the current list and 15 is present, hence we got true. Now we'll be discussing about the iterator. We use the iterator to iterate through the array list. So we'll create an iterator of integer itr as al.iterator. While itr.hasNext will traverse through the list. Current will be itr.next and we'll print this current element and a space. Finally, at the end, we'll be printing a new line. The array list contains 3 elements, 15, 3 and 4, which we have printed using the iterator. The last method we are going to discuss here is the clear method. It clears the array list, that is, it removes all the elements from the array list. After this method, there is nothing left in the array list. Let's print the list. We can see that the list has become empty. Let's take a look at some of the key advantages that make ArrayList one of the most commonly used data structures in Java. Dynamic resizing. ArrayList can automatically grow or shrink in size as needed, unlike traditional arrays which are fixed in size. Fast random access. It supports indexed access, so retrieving elements by index is very fast, that is, in constant time. Ordered elements. ArrayList maintains the insertion order of elements, which makes iteration predictable, easy to use and implement. With built-in methods like add, remove, and contains, it is very simple to work with. Also, it reduces the boilerplate code, allows duplicates and nulls. You can store duplicate value and even null, which adds flexibility when dealing with different types of data. Overall, ArrayList is a great choice when you need a flexible, resizable list with quick access and simple usage. While ArrayList offers many benefits, it's also important to understand its limitations, especially when performance or memory usage matters. Slow insertion and deletion at beginning and middle. Inserting or removing elements anywhere other than the end requires shifting elements, which can slow things down. No direct capacity access. Java does not provide a direct way to check capacity, only to ensure it using ensure capacity, not thread safe. ArrayList isn't synchronized by default, so in multi-threaded environments, you will need to handle synchronization manually. Inefficient for frequent modifications. If you are frequently adding or removing elements at the beginning or middle, ArrayList may not be the best option. Potential memory waste. To avoid frequent resizing, ArrayList may allocate more memory than needed, leading to unused space. To get the most out of ArrayList and avoid potential performance issues, let's go over some best practices when using it in real-world applications. Set initial capacity when possible. If you already know how many elements you'll be storing, it's a good idea to set the initial capacity using the constructor. This helps reduce the number of internal resizes, especially for large datasets. Use ensure capacity for bulk inserts. When you are planning to add many elements at once, calling ensure capacity ahead of time can optimize performance and avoid repeated resizing. Avoid frequent insertions and deletions in the middle. ArrayList is not optimized for modification in the middle of the list. Each insert or delete requires shifting elements. So for that kind of use case, consider using a linked list instead. Be careful in multi-threaded environments. Since ArrayList is not thread safe by default, you should wrap it with collections.synchronized list or use copy on write ArrayList if you are working in a multi-threaded environment. Following these best practices helps keep your code efficient, clean, and safe, especially as your application scales. Now that we have covered the best practices, let's take a look at some common use cases where ArrayList is the ideal choice. Storing ordered list of data. ArrayList maintains insertion order, so it's great when you need to keep elements in the exact sequence they were added. Fast access by index. Thanks to indexed access, you can retrieve any element in constant time, perfect for applications where fast lookups are required. Read-heavy operations. If your operations mostly involve reading data with fewer insertions or deletions, ArrayList provides great performance. Temporary buffer or caches. Need a dynamic and resizable container for intermediate or temporary data? ArrayList works well as buffer, especially when size requirements vary. So whenever you need an ordered, resizable list with fast read access, ArrayList is a solid go-to solution in Java. We will look at a real-world scenario for using an ArrayList. We will create the functionality of a shopping cart. Let's go to the code editor. Before creating the shopping cart using the ArrayList, let's first analyze the design we are going to use to create the shopping cart. We'll define a product with name and price, and our shopping cart will contain multiple products. And this shopping cart will be managed by our main class, which is named e-commerce cart. This main class will perform few operations like adding products, removing products, viewing the shopping cart, and calculating the total of all the products present in the shopping cart. Let's begin by defining the product class. We'll be having two properties in it. First is the string name and second is the double price. We'll define a constructor for this class. Also, we'll define getters and setters. Finally, we'll override the toString method to print details of this product. Our product class is complete. Let's create the shopping cart class. This class will be responsible for adding, removing, viewing, and calculating the total of all the products present inside the cart. To manage all the products, we'll create an array list of product. After that, we'll define a constructor for this class, which will initialize our cart as new array list. Let's define the functionality for adding a new product to this cart. We'll simply use the add method of ArrayList to add a new product. After that, we'll just print a message. Product.getName added successfully. Now we'll be implementing the functionality to remove a product. We'll be removing the product by its name. To remove a product, first we will check if the cart is having that product or not. For that, we will traverse in the cart. And if the current product is the product we are searching, in that case, we'll use the remove method of ArrayList to remove the product. Product name is removed successfully. We'll return from the function here. If we come out of the for loop, that means the cart does not contain the product. We'll simply print that product name present in the cart. Next, we'll be implementing the functionality to view the cart. We will start by checking if the cart is empty or not. If the cart is empty, we'll simply print cart is empty. Otherwise, we will traverse through the cart to print all the products. We're implementing the function to calculate the price of all the products present inside the cart. We will initialize the total as 0. And add the price of each product to the total. Finally, we'll return this total. That's all for the functionality of shopping cart. Now we will use our driver class e-commerce cart to add products to this shopping cart and use the functionality that we have just created. I have created few demo products. Let me paste it here. Now we'll be creating a new shopping cart. We will add all these products to the cart one by one. After that, we'll view the cart. The output contains the insertion of 3 products successfully to the cart, and the viewCart method returned the details of all these products. And print the cart after that. We can see product smartphone is removed successfully, and after that the cart contains only 2 products, laptop and headphones. Finally, we will calculate the total price of all the products present inside the cart. And let's print this total to the screen. The total price is 1199.98. We have successfully implemented a shopping cart using the ArrayList. Thanks for watching. That's it for this video. Don't forget to like, share and subscribe. We'll see you in the next one.